Hey guys, today we're going to talk about matter. Matter by definition is something that has mass and takes up space. Both of these items have to be true for a substance to be considered matter. So if the substance has a mass, it is matter. For example, gases. Gases are very lightweight. The individual particles are very, very small, but they take up space. If you spray a can of room spray, it will slowly work its way from wherever you sprayed it across the entire room. So it has mass, and the particles expand to take up space. So those count as matter. Sunlight, for example, does not count as matter. Sunlight is energy that is traveling through space. It is not an itty-bitty piece of the sun being thrown at you. So when you have a sunburn, your skin is absorbing energy, it is not absorbing pieces of matter. There are characteristics of different types of matter that we're going to be talking about. The first one is a solid. So if an object is solid, it has a fixed volume. The volume stays the same in all situations for that example or that substance. So hypothetically, if I had 5 grams of lead, those 5 grams will always have the same volume or take up the same amount of space and have the same mass, 5 grams. It will also have a definite shape. That piece of lead will always be the same cube-shaped piece or the same spherical-shaped piece. It has an organized molecular structure, meaning that the structure is always neat and orderly and tidy, but those molecules cannot move freely. They vibrate to transfer energy. So we're going to focus on these two examples. The first one, the organized molecular structure. I'm going to draw a molecular diagram of a solid. So if that's our first row of molecules, our second row is going to be nice and neat and orderly. And our third row is going to be like bricks. So they're kind of alternating and stacking nice and neat together. And I drew 20 molecules. That's important because on the next slide we're going to make a particle diagram of a liquid, and I want to keep the same number of molecules. Now this next example, they cannot move freely, but they will vibrate to transfer energy. Imagine this square with these little red particle diagrams as a pot on a stove. If you put water in that pot and you want to boil it to make your macaroni and cheese for dinner, if the heating element is beneath the pot, it's going to give energy to this bottom layer of particles. And that energy is going to make that particle move up and then down, and then up and then down. And once this bottom row of particles starts moving, the next row is going to start shifting with it. It's going to shift forwards and then backwards, forwards and then backwards. And then the next row of particles is going to start shifting. Now, if you are a solid substance, it does take some time for that energy to travel through that entire amount of material. But the point is, it does travel. For example, if you have a spoon and you're making some hot chocolate and you're stirring the hot chocolate with your spoon, you take it out to lick it, to put it in the sink, the bottom of that spoon is going to be really hot because of the hot water. The middle of the spoon might be warm because those molecules started moving forwards and backwards. It just didn't travel all the way to the end to where your hand was holding it yet. Eventually it would, it just hasn't at this point. So the next substance that we have is a liquid. Again, a liquid has a fixed volume. If I have 5 grams of water, the volume is going to be the same at all times. It has a fixed mass. 5 grams of water will always have a mass of 5 grams, but it has a changing shape. That 5 grams of water will take the shape of any container that I put it in. So it could be in a little bowl, it could be in a cup, it could be in a thimble. It doesn't matter because it takes the shape of that container. It has a slightly less organized molecular structure. It can move freely, but flows throughout a substance. And it is considered an incompressible fluid. So we're going to focus on these last 3 bullet points because these are the ones that are kind of new. Less organized molecular structure. On the last slide, we had 20 molecules. So I want to make sure that we draw 20 again. On the last slide, they were in the bottom third of the box. So now we're going to spread out a little bit more. So 20 molecules. And notice they're spread out a little bit more. They're not as organized. They're not nice and neat and orderly. And what can now happen? These individual molecules can move in between each other. They can flow around this container. They can move in between other particles if they need to. A lot of people notice this and they see this if you are boiling water for your spaghetti before you put your spaghetti or your mac and cheese in, and you start seeing those bubbles doing that swirl. That is the liquid heating and flowing through other liquid molecules as the rest of the container heats up. Now, I like to compare the states of matter to dancing. A solid item is like an awkward guy on a dance floor. Their feet are planted to the ground and they just shift their weight left and right. So they just kind of hear the music and they move to the left and then they shift back to the right. Their feet never actually leave the floor, they're just shifting their weight of their body. A liquid is how you would see a ballroom dance. Somehow they're always flowing nice and gracefully, they're always moving in an organized pattern, and for some reason the molecules never actually run into each other. So solids are awkward dudes on the dance floor, liquids are like a ballroom dance. Now this bottom line, incompressible fluid. This means that if you were to put this fluid in a syringe and you cover the tip of the syringe and press as hard as you can, the syringe can't get any smaller. The volume of 5 grams of liquid, whether it's water or not, will always stay the same volume. You can't force those particles any closer together. So the last one we're going to talk about is a gas. Now the gas has the most that changes. It has a changing volume, which means that you can compress the gas down or let it out to fill a room. It does have a fixed mass. If you start with the same number of gas molecules, the mass of that gas will always be the same amount. It has a changing shape. The gas will fill whatever container you empty it into. It has the least organized molecular structure. The particles have a high range of motion and they can move freely, and this is considered a compressible fluid. So again, the last 3 bullet points. On the past couple slides, we've had 20 molecules. So here I'm going to draw 20 molecules again. I'm going to take up the entire container. So 1, 2, 3, 4, 5, 6. So I think that's 20. Let's pretend this one actually was a complete sphere. Well, maybe 21. We'll pretend it's 20 though. This is the least organized molecular structure. They spread out to fill every crevice of the container that they can. They have the highest amount of energy. So if a solid was an awkward dude on the dance floor and a liquid was a ballroom dance, a gas is now a mosh pit. Those particles are going to be running into each other and bouncing off of each other as much as they possibly can. But this is a compressible fluid. So if you've ever seen anyone using air compressors or an air tank, the oxygen is compressed into that tank. If you let it go, it can fill a room and expand as much as it possibly can, but it can be smushed down into a small container. So for example, air freshener. Air freshener has like 3 ounces of air freshener in it, but as you let go of that trigger, it will fill the room with the smell. So it will spread out and fill the entire room with the smell of that air freshener because it can expand or contract. The last example that we have is plasma. Plasma is a superheated, charged gas. What that means is it is technically a gas, but it is very, 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 very high temperature, and it actually has an electrical charge. So it acts a little bit differently than regular gases, which is why it's its own category. And it is actually affected by electrical and magnetic fields. So plasmas are things that I want you to know that they exist, but I don't want you to actually do much with them. So just know that they are the highest energy substance, and they are something, and they are present in the universe. Now, when we meet in class tomorrow, we are going to take the time to classify and to practice classifying matter, and then we're going to move on into different characteristics and different types of matter in these three categories. I'll see you then.